Today we're going to be talking about Maya tool development and the options you have. We're not going to deep dive into the specific options, but we're going to look at them all at a high level overview. There's a blog post that complements this video at learncreategame.com/techart/Maya tool development overview. There will be a link to that in the description. So within Maya tool development, there are two main options. There's the Maya API programming and Maya scripting. We will mainly focus on the scripting because it's much more approachable, and it's what I use at least most of the time as a tech artist. And you can do a lot of tools through scripting, and it's very fast to iterate. But let's briefly touch on the Maya API and what options are available to you. The Maya API is designed to be as high performing as possible and results in a plugin for Maya. Maya ships with three choices that you can choose for API programming. The first choice is C++ API. The second is maya.openmaya, also referred to as Python API 1.0. The third and last option is maya.api.openmaya. This is also referred to as Python API 2.0, and it's faster and more Pythonic. We will talk about what Pythonic means. That's kind of like a red thread going through this whole introduction to Maya tool programming. So this API is newer and still under development, so not everything that's available in the Python API 1.0 is available in Python API 2.0 yet, but you can mix and match them. So now let's take a look at the different scripting options in Maya, and I will introduce them in historical order, and it also makes sense from a functional standpoint that I save the best for last. Let's start out with good old MEL. Maya embedded language has been in Maya since its inception in 1998. I would really recommend you scripting in MEL if you have a choice. I guess if you're scripting tools for Maya LT, you don't have a choice because they have yet to add a Python interpreter to the Maya version. But you're getting just so much with switching to Python that MEL can't really do. So let's take a look at the syntax here quickly. So we have to declare our variable type when we create variables. So if I select this here, I have a string. The string is stored for the name of this object. So MEL is not object oriented. It's a scripting language. You can think of it as dispatching. It's building up commands and then it's dispatching those commands for Maya to execute. If I want to change the variable type here from a list to a regular string, I cannot do that. I can't dynamically change variables. Another thing is when I'm scripting, I can't just select a variable to see what value I have somehow. I have to create a new line every time and just do a print statement for that over and over and over. I remember doing this a lot. Now I can see what that is. So here we store the shape node for the first of the list in the selection. Using the list relatives command of type shape, and then we're storing the type, and if it's a mesh, we select the border vertices. So now let's go into Python land. Just switching to Python is a huge win. There's lots of built-in functionality in Python. You have a complete file system package, very powerful string operators, XML, JSON, and database readers and writers. The list of features is very, very long. You can check out the blog post for more details. The Python interpreter itself was added in Maya 8.5. And Maya then introduced maya.commands. So let me get the selection here. So I've pasted the MEL commands over here to just illustrate how similar the Maya's Python implementation for its syntax is to MEL. So we import the maya.commands module. And some nice wins here right off the bat. You no longer have to declare your variable type. You can just store the selection here, and you can see that this is a list of a string. So now I can switch that to be just a string by storing the first. So now we have a string. So that's very, very nice. And you notice also I can just select the variable, hit enter, and see what that variable is. That saves a lot of time when you script. So you can see here that in Mel we have ls as the commands, and then we have flags. And maya.commands ls, and instead of flags you have arguments that you pass to this function. So list relatives, if you need to act upon something, like for the shapes, we need to actually query the shapes off of the selection. We're going to remove this because it's now a single string. So now we have a list of the shape node here. So in Mel, you pass this as the last part to the command, and in Python, you do it as the first part followed by the arguments. But you can see how similar these are. And the fact that they're so similar led to some community criticism that the Maya or the Autodesk implementation of Python and scripting in Maya is not very Pythonic. Again, what is Pythonic? I will demonstrate that a little bit later, what it means. I think it'll become clear. So that basically led to a community developed effort to implement Python scripting in Maya called PyMel. It was spearheaded by Chad Dombrova at Luma Pictures, and I want to publicly thank Chad for starting this movement because it changed scripting in Maya. And I love the way it is implemented. So let's switch over to PyMel. In PyMel, you have a bunch of different packages that you can import. We're just going to import the general package here. And now I'm going to store the selection. So let's take a look at that value. So right now, we don't just get a string. We're getting, this stands for node type. We're getting a node type transform. Let me illustrate something really quickly here. Let's jump back to Maya commands and import that and store the selection. So we can see the selection is pSphere 1. So if I rename this to foo and I try to select it, it's going to break because it's building up the command to select and it's passing the string along for Maya to figure out. Let's undo that. And now if we go over to PyMel and again store that selection, we have node type transform. I'm going to do the same thing. And then we can do PyMel.core.general.select selection. It still works. The reason it still works is that this object has a link to the API node. So this object is not just a string representation. If I do dot here, this object has a lot of methods attached to it. So these all sort of you get for free with PyMel. So getShape is just a method that is attached to the transform. And this becomes really, really short and readable. You write way less code, and that's what Pythonic is. So let me illustrate. In Python, if you have a string, so let's do car underscore LOD0. One of the string operators that Python has is ends with. So if I want to do foo dot ends with and then LOD0, we get a true statement. So you can see that you're acting on the object, and that's sort of the Pythonic way. And that's what PyMel is set up to do. It's acting on the object. So we can daisy chain these two. So selection.getShapes result in yet another node type mesh, which also has a ton of different methods, or it has a bunch of methods attached to it. So mesh.verts, for instance, that's how we can get access to all the vertices of that. It's so powerful. It's not even funny. Yes, I'm very excited about PyMel. I've been there for many years now. So let's take a look here. This is a really good example. So if the type is mesh, we're going to store all the border verts. Now, something I do want to mention is that there is a slight cost because of the casting to the API nodes behind the scenes. There is a slight cost to PyMel, but I seriously, it's so minimal. And this is probably the worst thing that you can do, I guess, because for each vert that we're going through here, so selection get shape verts. So this is a PyMel mesh vertex object that has its own functions, and one of them is on boundary. So this will basically go through this 200 vertice object and store all the border verts if we select this, if we manage to select the line and run it. So there are the vertices that's on the border, and then we select them. Let me show you a quick thing here. Selection dot translate x dot set to, and you sort of get the gist of how it's just acting on the object, and it's just daisy chaining that, so that becomes very, very readable. And if you wanted to get, you just change that statement to get instead of set, and you get the float of that. So another nice little trick here is, what if I wanted to create a PyNode object? I have the string of this. So I have foo. So you can do PyMel.core dot PyNode and that foo. That basically casts it into a PyNode object, and it will do the correct one. So this, it casts correctly for every Maya node there is. So if I have a joint, for instance, and I store the selection of that, now that is a node type joint, and of course it has a ton of, so rotate or orient joint. Yeah, it's very, very powerful. So that's PyMel. So if you've been sort of writing in Python with Maya commands, you've been wondering what this PyMel thing is about, I would highly recommend take a hard look at it. I will include the link to the PyMel documentation, which is really excellent. It's all on GitHub, and it's community supported, so it's very well documented. So that's PyMel. So that wraps this video. If you found it useful, give a thumbs up and subscribe to the channel. If you have any ideas for topics within TechArt that you would like to know more about, please send me a message or comment on the video below. Thank you.